Hey, welcome to another exciting episode of Adventures in DevOps. I'm your host, Jonathan Hall, and here in the studio with me also today is Mr. Will Button.
What's going on, everybody?
Hey, no guest today. It's just us. We're going to wax philosophical about HTTP, REST, gRPC, maybe a few other fun acronyms and stuff in there too.
Every time it's just the two of us, I hear that song from Austin Powers, The Spy Who Shagged Me, where Mini-Me and what's the evil doctor's name?
Dr. Evil.
Oh.
How do you forget that?
I'm gonna grab some more coffee.
What's Will's name again? I can't forget. I can't remember. What's Will's name?
But they do the duet of just the two of us, and it always cracks me up.
All right, great. So it's just the two of us, and
Just the two of us.
it's going to be great. Or terrible. I don't know which one yet. We'll find out. So I was having a conversation on a Slack group I'm on about gRPC versus REST, and a few of the other things that might be kind of thrown into that category. GraphQL and SOAP, even, if you're really old school.
Oh, yeah.
JSON RPC, and who knows what else. There's a bunch of things in those sort of categories. And we were discussing, so I kind of have this theory that a lot of times this discussion about these two comes out of an ignorance of the problem you're trying to solve. Because I see REST and gRPC as solving very different types of problems. But anyway, I wanted to throw that topic out here, throw it on the floor, tear it apart. Maybe we could put it back together again before the episode's done.
All right, cool. So I've got very limited experience with gRPC. Obviously, because I can't even get the name right. So, so throw it out to me at a high level. Like, I'm really familiar with REST, so maybe give me the pros and cons.
Okay.
Of the two.
So, I mean, maybe just a really basic history lesson about REST, which I'm probably going to get some of the details wrong, but it's the broad strokes that matter. REST is more or less the web, right? You know, it was designed for, this is an oversimplification, but document storage and retrieval. And REST is itself, I should look at what it stands for because that would be a really useful thing to know. So REST itself stands for Representational State Transfer, which isn't really that useful of a thing to know. But it more or less describes how to retrieve things from a web server and how to store things in a web server and how to delete things and update things in a web server. And
right.
You know, it's broader than just the web, you know, because the web is more or less a static thing. I mean, you can do things on the web that aren't static, but there are also things in REST that are broader than you can do like through a web browser. But there's also stuff you can do over HTTP. I think so. Let me start with a really high level oversimplification of where I think gRPC and REST make sense, and we can start to tear it down a little bit. I think REST makes sense if you're storing and retrieving documents, and gRPC makes sense if you're calling functions.
Okay. That seems reasonable. Can you give me an example of why I would want to allow someone to call functions?
Yeah. So a common example would be, I mean, a lot of, in fact, maybe the majority of even REST APIs are really RPCs, or they have an RPC element to them at least. So let's say you're doing a I don't know. Let me think of an example. Let's say you're doing a validation of some sort. You want to validate whether maybe you have a file that you want to validate with valid HTML. That's a really simple example, right? Mm-hmm. So you upload it to an API and it returns back maybe a list of, maybe it says everything's fine, or maybe it gives an error, or maybe it gives a list of errors. It says, oh, you're missing a closing thing here, or this isn't a valid character, or whatever it might do. You might give you a list of 15 different linting failures or something on your HTML. That's really not a document retrieval. I mean, I'm sending a document and then I'm getting back a result, and that result could be formed as a document. And that's usually how a REST API does it. But really, I'm calling a function and say, perform an action on this function and give me a list of results. So that's a place where, although that's a trivial example, that's a place where we're using the remote server to execute a function. We could just as well execute it locally if we had the software running locally.
Right. Gotcha. And then in the return response, if you're using REST, it would have to be formatted as a document that then you would then parse to being an object in your code so that you could interpret the results. But with gRPC, it's going to return just the object itself? Or does the gRPC actually give you the function and say, here, you do it, damn it?
So what gRPC does, and so, I mean, there's maybe two levels we could talk about, but I'll talk about gRPC first. What gRPC does is you define your function calls, sort of your function signatures, the data types it accepts and returns, and so on. You have to define that ahead of time in a protocol buffer or gRPC definition file. But then once you've done that, then you sort of have this generated server that handles it for you. So aside from network latency and things like that, you can more or less use your gRPC call as though it were locally running code. You just call the function and you get a result, and it encodes the arguments to the function, encodes them in a special way using protocol buffers, sends it to the server, gets the response, and then does the reverse on the response. It decodes it, turns it into a normal object in whatever language you're using, and gives it back to you. So from an API standpoint, as you're writing code using the SDK, it looks like you're just calling a function that's a little bit slower because there's a network. And of course, you can do the same with REST if you take the effort. Maybe you're using even Open API or something like that, or maybe you manually build your little layer around it. So I think this is why this conversation comes up all the time, is because you can do the same things over REST as you can over gRPC, but you have to sort of reinvent the wheel every time.
Gotcha. So that's the big selling point of gRPC, is that it handles a lot of the boilerplate stuff for you, so you can focus on just the part of your code that adds value to your business.
That's a really big part of it. I think there's more to it than that, but that's a big part of it. I mean, and the reason I say more than that, because there are probably libraries, depending on which language you're writing in, whether you're using Python or Go or whatever. I'm sure you can find libraries that will do kind of the same boilerplate thing for you with REST.
Yeah.
But gRPC gives you a few other things that REST, no matter how nice and polished it is, can give you. And maybe the most important one, at least in my view, is the semantic difference. I don't know if you've ever had the conversation with somebody about which HTTP response code should we use. Should it be a 400 or a 423, or is it a 401 or a 403, or what's this teapot response code? And all these weird conversations we have.
Actually, I've never had that conversation. I just always return HTTP 200, and then if there's an error, I'll just put that in the message in the response.
That solves all the problems. Yeah. All right, I can end the episode.
And just for reference, I am kidding about that. I've seen that done on multiple occasions, and that is not the proper way to handle that. That is just to be clear there.
Way. Yeah. So there is a proper way, or a subset of proper ways to do this with REST. The problem is that they don't cover all the scenarios. And so, very frequently when somebody's asking the question, what's the proper response code to use in my REST API for this scenario? The sort of philosophically correct answer is don't use REST for that. Because if it's not obvious which response code to use, REST wasn't designed for your use case. A really common example, and actually the one that brought up this conversation on Slack the other day, was what's the proper response code for a batch request when some of the items in the batch fail?
Gotcha.
So using our example, I've uploaded 10 HTML documents and 3 of them have failures. Do I return a 200 because 7 succeeded, or do I return a 500 or 400, whatever, because 3 failed? What's the correct response? And the correct response is REST isn't designed for that.
Yeah. Yeah, now that makes a lot of sense, because I've encountered multiple scenarios where there's just not an HTTP REST code that seems to fit the data that I'm returning.
Right. Now, there are ways that you can get around that in REST. A very common scenario in REST is you return a 200, and then in your message, just like you sort of facetiously described, you return a 200 because the request itself succeeded. Mm-hmm. but some parts of it failed. So then in the payload, you have to describe which ones failed. But then you have to just invent a protocol. I mean, you're probably using JSON or something, or maybe XML, but you still have to invent how am I representing that 3 of my 10 things failed in my JSON. And so you're reinventing that wheel. If you use gRPC or any other well-defined RPC, then hopefully that's already handled for you, and it's just like calling a function.
Yeah, because if you're in the HTTP REST world, at that point you're relying on the developer to see the response code and then evaluate the data to see whether it was successful or not, which can be really problematic if the person consuming your API is not in close communication with the people building that API.
So, I mean, there are other ways to do RPCs. I mean, RPC is a broad, RPC meaning remote procedure call, is a broad category of things. gRPC is far from the only one. It's maybe one of the more popular ones these days. Who knows how long that will be true? Maybe something shinier will come along next year, and we'll all be switching to that. But it is nice. I mean, I've also played with JSON RPC, which by comparison feels like a children's toy. But it gets the job done if that's what you want, and you want something simple. Maybe it's worth talking about the disadvantages to gRPC.
Yeah, for sure.
Probably the biggest disadvantage is sort of, well, two related. One is the learning curve, and closely related to that is the fact that you have to predefine everything ahead of time. That's both a curse and a weakness, or it's a strength and a weakness. So you have to, as I was describing earlier, you have to describe each function call and every data type that it might send or receive in a protobuf definition. And that just means extra work ahead of time. And it means you have to learn how to write protobuf files, and so it's not a complicated syntax, but you have to learn it. It's easy. If you can write JSON, you can write this, but you have to learn a few data types, and you have to learn some tricks about if you want to add a field to a data struct in protobuf, you have to do it in a certain way so that it remains backward compatible, and so on and so forth. There are some things to learn, so it's not terrible. It's not overcomplicated, but it's something.
No, but I can definitely see that as being a barrier to someone adopting it because, a lot of times in software development, we don't like to think very far ahead. We just want to solve like the current thing right now so we can close the ticket and move on.
Yeah. And then if you're using microservices, then you have to propagate those files between your services that are talking to each other.
Right.
That's not a unique problem. I mean, if you're using JSON that you invent, you have the same problem. It just maybe isn't as formalized often. Like you just kind of have this implicit understanding that I'm going to send an integer here and a string there, and I expect that the recipient knows that.
Right. Yeah.
And hopefully they do, but it's usually not codified. JSON is it's trade-offs, right? With JSON, you have this immense flexibility that can be great, or it can shoot you in the foot. And with gRPC and protobuf, you have a lot more strictness, but that can be great, or it can shoot you in the foot. So it's not like one solves all the problems of the other.
Yeah, it seems like it's just more so where do you want to solve the problem at? Do you want to solve it in a strongly typed definition back on the server, or do you want to just send out JSON and rely on the consumer of that to do parse int or toString or whatever they feel like they need to do to interpret that response?
I've also mostly seen gRPC used for internal communications. Like I've never seen a public API using gRPC, and it would be kind of strange to do that. I mean, it would be possible. You could publish your protobuf definitions, but usually I've seen gRPC used for internal service communication, and then the external API exposes something a little friendlier. It's not really the right word, but more ubiquitous. Something maybe with an open API spec with JSON and something like that. Which isn't necessarily appropriate because if you're Google Maps and those API calls essentially are RPCs, then you're back to the original chicken egg problem of abusing REST for things it's not designed for.
True. With gRPC, is there something similar to OpenAPI where you can see like what the parameters expected and the return values are?
gRPC supports something called reflection. It has to be enabled on the server, and of course, generally, I think you would enable it in your development environment, but not in production, for example. And I don't have a lot of experience with it, but I know it's there. So it basically allows you to query a server to determine what functions are available, what data types does it expect, and so on and so forth. So it with this reflection capability, you can do a lot of that, and it's probably a lot more powerful than like your typical REST API, because you can query the server directly to get the information. You don't just rely on its third-party documentation that
Right.
OpenAPI spec is.
Yeah.
I don't know what the security implications are of running it in production. Maybe none. Maybe it's just performance. I don't know. But my experience tells me, my limited experience in this area suggests that reflection is usually done in a development environment.
Okay. I guess since everything in gRPC is fairly well defined, if you wanted to, you could just create a consumer library that has those. Like if you're using TypeScript, you could include the type definitions in your library and then let people use that.
For sure. In fact, that's exactly what I was doing on the last project where I was using gRPC. It was all written in Go with Go microservices, but we would basically the pattern we were aiming for was we would have our protobuf definitions. Those generate the client and server SDKs, and then we write a thin wrapper around those SDKs that had the API we wanted to talk to. So we wouldn't, calling a gRPC service directly with this SDK is a little bit cumbersome. You have to, there's some indirection, and it's a little bit funny, at least in Go. And it was just not the friendliest API, but that's a natural result of generated code. If you use OpenAPI to generate your code, you have the same problem, only probably worse, at least in Go. We would have these generated client and server SDKs, and then we would write our thin wrapper around that just made it friendlier. And the pattern we were aiming for in these services, that each of our public APIs for the client would have two implementations, one that talked to gRPC and one that just called the library directly. So if you didn't want the overhead of talking over the network, you could just make that a dependency into your package. If it made sense, depending on the service we're talking to, if it wasn't a third-party service. So, and that's a nice thing. I mean, gRPC or otherwise, that's just a nice sort of pattern to follow, to have two implementations, one that uses the network to talk to a shared resource, and one that just does the calculation, your HTML validation, if you will, locally.
Right on. So you mentioned one other implementation that I do have some experience with that follows the same pattern of GraphQL.
Mm-hmm. So I've never used GraphQL, but I've read about it, and I may be using it on a future project. So I might have to be asking you questions here, but my understanding of GraphQL is that it solves yet a third problem. It's a little more similar to REST in terms of like the problem space, but my understanding of GraphQL is that it was invented to optimize for bandwidth utilization over mobile networks. Mm-hmm. It came from Facebook, right?
I'm not sure if it came from Facebook. Seems like that's something that they would do. And I like the concept at a high level, but it's very easy to fall over into the abuse scenario with that. And I had one particular scenario that I got burned with really bad, and using GraphQL, and so I'm forever bitter. I have this thing where I'm just not going to let it go. Right? But like the thing with GraphQL is you can the original intent was you can formulate this query that only returns the parts of the data that you're interested in or that you need to consume. And where I saw it abused was the consumer was grabbing data and then making business logic decisions client side with that data. Mm-hmm. And in this specific example, they were pulling down metrics and using that to calculate financial metrics. And turns out that their math was bad, and
Oh,
that set of metrics made it all the way up to the board of investors, and then we had to backtrack all
oh,
of that. So I think that's the reason I'm not really a big fan of GraphQL, just because I think there's certain parts of your data that need to be strongly typed in code and go through, the peer review process, and not put yourself in a scenario where someone could make a seemingly reasonable judgment call that says, hey, I've got this piece of data and this piece of data. They look related, so I'm going to use that to derive a third piece of data, when in fact that may not be the right pieces of data to use for that scenario.
yeah. I have two problems conceptually with gRPC. I shouldn't say problems, but caveats. Places where they could be used inappropriately. Um, and yours touches on the second one. So the first one is that I think it's huge overkill in a large number of scenarios. Like if you have 3 REST calls that your client makes, you don't need gRPC. Just build up those 3 REST calls and that's it. And you're done.
Right.
It makes sense when you have a huge number of combinations of types of calls. Sometimes you're getting a list of users with just their IDs. Sometimes you need the last name and first name. Sometimes you need everything about the user. If you're making all these different queries on the same data in different formats or different amounts of data being returned, I think that's the place where it might make sense. I've usually seen it used where somebody just built a simple API and they thought GraphQL sounded cool. So now you can query your users 16 different ways from Sunday, but only one way is actually being used in the application.
Yeah.
That's just waste. The second one, which I think touches on what you're talking about, is, and this is a subtle point. When you use something like GraphQL, you're moving your application boundaries. And what I mean by that is, usually your database layer is well within. If you're building a traditional monolithic application, your database layer is well within that layer, within that application. So you have your database layer, and then your business logic, or if you're using MVC or whatever, you have your model, your view, your controller. When you use something like GraphQL, your data model layer is no longer contained to your application. It's now exposed to the world.
Right.
And that's the problem you ran into, is that now your front-end application, whatever it was, I don't know if it was a website or a mobile app or whatever, but that front-end application, that data model existed there too, in places where the people building the GraphQL thing couldn't even see it was existing. So when you build GraphQL, it's from a responsibility standpoint, it's as though you're exposing your MySQL port to the world.
Yeah, for sure.
And if that's what you need in your application, okay, fine. But be certain that that's what you need and do it responsibly. Don't just go, oh, cool, this is going to solve all my problems. I'm done.
Yeah, and it's like, if you listen to that and you're like, yeah, that's exactly what I needed to do, that's the first indicator that you need to stop, take a minute, and rethink what you really need to do.
Right. So TLDR, I think GraphQL is probably a very powerful tool for the right circumstances, which Facebook and whoever else have, but most of us will never be experiencing. We don't need 16 ways to query our user stable, so you probably don't need that.
Yeah, for sure. And in several instances, I've seen where they've gone to GraphQL for performance reasons. That really wasn't the root cause of the performance reason.
Oh.
The root cause was poorly optimized SQL queries or poorly optimized code. It was all just like standard software development performance and tuning that hadn't been done. It wasn't a limitation of HTTP or the mobile device or whatever.
Right. So I think getting back to the beginning, I think the important thing is when you're choosing which technology to use for your API, first take a step back. Don't just pick whichever one's shiny or whichever one you're most familiar with necessarily. Take a step back and decide, what problem are you solving? Are you primarily storing and retrieving data? If so, then REST might be a good approach, or documents or something like that. PDFs, HTML documents, even user objects could be fun. Or are you manipulating them? Are you calling functions? If so, then you probably want some RPC, whether it's gRPC or JSON RPC or whatever. Or are you doing advanced data queries? Maybe GraphQL is the right solution then, but that's going to be a minority of cases, I think.
Yeah, yeah, agreed. And I think, that highlights something that, like, we're in the business of lifelong learning.
Mm-hmm.
If you're going to do this career, any technical career for more than 5 or 6 years, you're going to have to invest, uh, dedicated time each week on learning. And I think this is one of those scenarios. It's like if you first come into it and you only have a background in REST, you're like, oh, well, what should I be using? So now you've got to take a step back and figure out, well, what are the other options? And then what problems do they solve differently than REST would solve? And I think that's a really good place to go to documentation type sites. Like if there's a gRPC, if there's like an open, if it's an open standard and here's their website where they define all that stuff, that's probably a better place to start than, say, a YouTube tutorial on how to do gRPC. Because the YouTube tutorial will teach you how, but maybe not why.
Right.
Unless you're on my YouTube channel, #shameless self-promotion, I spend a lot of videos talking about why instead of how.
All right. Well, shall we go to picks then?
Let's go to picks.
Awesome. Do you have any for us, or shall I start?
I do. I'm going to stick with my pick from earlier and pick the Austin Powers series of movies because I just think they're hilarious. Set aside your higher level brain. It won't be needed. And just let your inner 13-year-old prepubescent self laugh out loud. So
that's about right. Yeah.
There you go. Austin Powers.
Nice. So my pick is going to be, it's an old book, but it's relevant to the topic, especially if you feel like you only have experience with REST, or maybe you want to get some experience with REST. It's a book, I don't know, I read it in 2015, so I don't know how old the book is. It's called RESTful Web APIs by Leonard Richardson, Mike Emundson, and Sam Ruby. It's an O'Reilly book with a sloth on the front, so I guess compared to gRPC, a sloth is about the right metaphor. But it is a good book. I mean, it really talks about how to design a REST API. Without this, it's not going to tell you when to use gRPC. Instead, it's going to assume you're using REST for everything, and it's going to talk to you about what status codes to use and how to do content type negotiation, and all the stuff. All those arguments about which status code to use, you'll win the argument after you read this book. So if you want to win the argument about REST, this is the book. If you want to expand your knowledge further and then learn about gRPC, that's highly recommended as well.
But that's secondary to winning the argument.
Yeah, but then you can win the meta argument. And then when your colleagues are arguing about 400, no, 4, blah, 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 you can say, hey, guys, boom, gRPC, conversation over. I guess that's it.
I think so. Nice
Great.
short episode.
Short episode.
Yeah.
Yep.
Thanks for listening, casual viewer or listener. Actually, they can be viewers now because we're on YouTube as well.
Yeah, we were on YouTube the last episode that came out as of this recording, which is probably 4 episodes or so ago as you're listening.
Yeah.
So I actually combed my hair today.
Right. Yeah.
So. For the listeners who aren't watching, I don't have any hair, so that's the joke. All right. Well, until next time.
Right on. Thanks, and we'll see y'all later.